Welcome to the Chlorine King podcast, where your host, Eric Taylor, will discuss tips for the do-it-yourselfer, answer listeners' questions, conduct product reviews, and host special guests from the pool industry. Grab your swimsuits and let's dive in.
Happy Labor Day, Chlorine Kids. In our day of rest today, I really hope you guys aren't working. You guys need some rest, kick back, and relax. In the meantime, I figured it'd be a great opportunity to share some education with you all. This episode today is going to be about total dynamic head, or TDH for short, and why it's important when selecting your equipment or diagnosing problems in your pool filtration system. But we'll get to that topic in a bit. Before we answer this episode's question, let's recognize our sponsors that make this episode possible. This show is brought to you by AquaSuite, the app to supercharge your pool business by keeping you organized and saving you time. Go to useaquasuite.com to learn more, and be sure to let Cameron know that Chlorine King sent you to receive a free 30-day trial. Also, Riptide Pool Vacuum Systems, the simplest way to save time cleaning your pools. With unparalleled performance and support, get your Riptide today at riptidevac.com. Let them know I sent you and they'll take great care of you. You're also welcome to support me on my Patreon channel at patreon.com/ChlorineKingPools. I got a question the other day from my YouTube channel subscriber, and I wanted to answer it here because it's a very common question I get almost daily. Dan asks, I have a side customer that I replaced the male adapter on a discharge side of the pump because it was leaking. 2 weeks after that, it was leaking again. I unscrewed all the unions, unthreaded the discharge pipe, applied Teflon and thread sealant, and it stopped the leak. I knew it was only temporary. So today, about a month later, the thing's dripping like crazy. Now the customer wants me to fix it on my Labor Day. I just tried taping it and threading it back on, but the threads don't seem to catch now. The pump basket was pretty warped, so I'm wondering if the threads in the housing are as well. What do you think? I just don't want to do a bunch of plumbing, redoing the whole pressure side, and then the male adapter leaks again. Thanks for the question, Dan. First off, I hope you aren't working today. You need a break, as we all do. Secondly, this problem, I'm afraid, is going to be virtually impossible to solve permanently. The reason is because at some point, the water got so low in the pool, the pump heated up the housing pretty good. And also, as you saw, the pump basket was pretty well warped. That's a good indicator to validate this as well. When this situation happens, the housing expands, which creates that leak you're having an issue with. The problem is, once it cools off, it rarely shrinks back down to the size it left the factory, which is why you're having this chronic leak. There's really not much you can do that hasn't already been done. I've seen people take pool putty, which is essentially epoxy that hardens like concrete, but that is what I tell my clients is the last resort and past the point of no return. Once you do that, you're basically left replacing the entire pump if it fails. It can work though, but it's only temporary in most cases. In the future, before you do that type of repair, do what I do. I always tell my clients that this is not a guaranteed fix, and it's because it's mainly impossible to see the damage that's done. Sometimes it will work, sometimes it won't. Make sure they know that before you touch it, and you'll find that you won't be in that position that you find yourself in now ever again. So thanks so much for your question, Dan. As we're moving on to the main topic, total dynamic head, or TDH, I'd like to make a blanket statement. All these figures I'm going to mention are based off the APSP's recommendations for the pool plumbing to not exceed 6 feet per second on the suction side and 8 feet per second on the return side of the pool plumbing. Also, this is going to be a little more than a brief overview, but not super technical, as I'm not trying to lose anybody in this information. The whole idea of this podcast is to get your mind thinking before you throw just any equipment onto a given pool. Now, with that said, pool equipment today is not what it was 5 years ago or even 10 years ago. Generally speaking, pumps today are more efficient and can move more water than ever before. So a 1 horsepower pump today is stronger than that 1 horsepower pump you're about to replace. Now, total dynamic head, or TDH, is the water's resistance you have in the pool's filtration system. And every system is unique, and because of this, it's impossible to take one pump and one filter and put it on every single pool and be fine. For example, a 2 horsepower pump with 2-inch plumbing on a 30,000 gallon pool could be appropriate, But if you put that same 2 horsepower pump on an 8,000 gallon pool with 1.5 inch plumbing, you'll see it's grossly oversized for that pool, and we'll get more into that later. Now the end goal of knowing your TDH is so we can choose the right equipment, right? We also need to know other factors such as the pool gallonage, the turnover rate desired, the pipe size, and things of that nature. But those are the more commonly known and discussed things, so let's stay focused on TDH because this plays an enormous part as well, and it's often overlooked. So let's talk about what the general pipe sizes are and their normal operating range, if you will, to still maintain the APSP's maximum recommendations. Remember, the goal of this is to not pass those numbers to keep our swimmers safe. Also, as the pipe size increases, the amount of water it can handle is much greater. Not only that, the velocity of the water decreases along with the friction loss and pressure. So, generally speaking, an 1.5 inch pipe can handle 30 to 50 gallons per minute. 2-inch pipe can handle roughly 50 to 80 gallons per minute. 2.5 inch pipe can handle 80 to 120 gallons per minute. And 3-inch pipe can handle 120 to 180 gallons per minute. Now again, can each size handle more? Sure, to a point. But if you consult a pipe size velocity chart, you'll see the figures I gave are the minimum and maximum for suction and return pressure to again fall within the APSP's recommendations. There are 2 main considerations when choosing the pipe size, and this again has more to do with new builds. On an existing pool, you're sort of stuck with what's there, but that is the velocity and friction loss. Velocity is the speed at which water flows through the pipe. It's measured in feet per second. Friction loss is a loss of pressure or flow due to the resistance or friction in the wall of that pipe. So a quick quiz for you all. How can the water move slower on the suction side of the system than on the return side? The answer is this: it's all in the pipe size. As the pipe size increases in diameter, the water slows down. Now that we have a pretty good understanding of what TDH is, how can we overcome it? The pump is the heart of the filtration system. Think of the pump as your heart. What does your heart do? It pumps blood through your body to deliver oxygen and nutrients. The pump for your pool does the same thing. It pumps water through the filtration system to keep the pool clean and safe to swim in. The pump has to overcome all the resistance in the system to keep the water flowing and the water safe, as mentioned above. The pump output is measured in gallons per minute. So say a 2 horsepower pump puts out 80 gallons per minute. Does that mean it's going to do 80 gallons per minute on every single pool? The answer is no. It's going to try, but it may not be able to. And that leads me into my next topic, and that's the circulation system. Now keep in mind, the higher resistance we have, the less flow we're going to get. If we have less resistance, we're going to get more flow. The best example of this is for cleaning a dirty filter. When the filter is dirty, what happens? The pressure is sky high and there's barely any water coming out of the returns. Now what happens if you clean it? The pressure drops in the filter and you see a ton more flow coming back into the pool. This is how the resistance and flow relationship works in every single pool. What are some items you can find on an equipment pad that can cause friction? Things like the pump itself, the filter, the heater, chlorinator, valves, and cleaners are all things that can increase TDH. What is something that isn't mentioned here that can absolutely kill the flow? Yep, you guessed it, fittings. And how things are plumbed in can absolutely kill even the best equipment if it's not installed correctly. So let's move on over to fittings, because that's something that isn't really discussed and it is a killer. How many of you walked up to an equipment pad and it looks like someone had no idea what to do but made it fit? We're talking 90s after 90s, pipe having to crisscross to go different directions and things like that. That will absolutely, again, kill the flow rate and create a ton of resistance in your system. Now, I'm not going to go through all the different fittings that cause resistance, as that would take forever. But what I can do is give you some examples that will get you thinking. These figures are all going to be given in feet of head. And these numbers are also equivalent to straight pipes. So, if I give a figure of 4 feet of head, then it's also the same as 4 feet of straight pipe. Does that make sense? Okay, cool, then let's proceed. Now, a 2-inch 90-degree fitting, the common ones you always see that have a really sharp inside radius, cause about 8.6 feet of head. That one fitting is equivalent to 8.6 feet of straight pipe. So, knowing that, how many times have you seen a pump installed with two back-to-back 90-degree fittings? What that installer is telling you is that they had to fit 17.2 feet of pipe in that small 6-inch space. See how that increases the water resistance and just kills the flow of the pool? Now, a 2-inch sweep 90 fitting has only 5.7 feet of head, or again equivalent to 5.7 feet of pipe. That's a huge resistance reduction. Say you have 10 90-degree fittings on that pad, just for easy math. If you go with a standard 90-degree fitting, you have an equivalent of 86 feet of straight pipe in terms of resistance in those 10 fittings, whereas if you go with a sweep 90, you'll only have 57 feet of pipe resistance. See how that can make a huge difference in flow rate? You'll see a difference in filter pressure too. It should be considerably lower using the sweep 90s. Because remember, as the flow increases, the resistance decreases and friction decreases. Now, a 2-inch 45-degree fitting only causes 2.6 feet of head, or again, it's equivalent to 2.6 feet of pipe. So now you can see how fittings can really affect your TDH, which again ties into your system's functions, which again ties into the equipment that you should pick that's best for that pool. How many times have you been asked, what should my filter pressure be by a client if you're out cleaning the filter or whatnot? It's virtually impossible to guess that. It's based entirely on how the pool was built, how the equipment was installed, and how efficient the equipment is. So now I hope you guys can answer that question next time you're asked. Now that we have a better understanding of TDH and how the fittings and equipment can affect the TDH, how can we diagnose issues with TDH to see where problems lies? What every repair company should stock with their techs is a TDH manifold. It's essentially a setup that has a vacuum gauge on one side, a pressure gauge on the other, and allows you to monitor the circulation system. Think about how a doctor puts a stethoscope to your heart and measures how you're doing. A TDH manifold does the same thing for a pool. Where do you put it though? You know those tabs on the bottom of the pump that you can unscrew? You know those things that allow air to get in the pump and it's always the last thing you check? Yep, that's where. You take the vacuum gauge and put it on the one that's underneath where the pump basket goes, and you put the pressure gauge on the other connector, the one that's near underneath the impeller. Now you have your stethoscope hooked up to your pool. What are some things to look for? Generally speaking, if you have more than 9 inches of vacuum, there's some type of problem. Some things that could be the problem is the pump's too big, or there's something stuck in the suction line. Another reason could be because the pump is considerably above grade. It has to work harder. This causes the vacuum pressure to increase, and those are some of the things to look for if you're on the high side. But what if you're on the low side? If you're on the low side, some things to look out for is if you have a variable speed pump, check to see if it's in a low RPM setting. The pump could be well below grade, which means the pump doesn't have to work that hard because gravity is pushing water down to the pump and basically doing the work for it. You could also have a blocked impeller, or it could have spun off the shaft. Also check the amperage of the pump. Check to see what it's pulling. If it's pulling more than what the nameplate suggests, then you're going to have a decrease of vacuum pressure because it's starting to get burnt out and worn out. What happens if you have good vacuum but no pressure? Check the diffuser O-ring. A bad diffuser O-ring can cause the water to basically recirculate in the pump, which will give you that symptom of great vacuum but no pressure. So as you can see, there's a lot of different scenarios that can occur, but that's how powerful one of the TDH manifold tools can be for you. So let's look at a common example that sort of ties everything I've talked about together. A client is complaining their pool's green and is turning green every 3 days. This particular pool has a 2 horsepower pump on 1.5 inch plumbing. Bigger is always better, right? Not always. This system should pull about 80 feet of head. An industry standard, if you will, is to clean the filter once it gets 10 psi above the starting or the clean pressure. So the first thing you tell the client is the filter's good because it hasn't hit that pressure point yet. In this case, you're not looking far enough into what's happening. As a 5-pound increase in the pressure happens, you get roughly an additional 13 feet of head. At a 10-pound pressure increase, you can see up to an additional 23 feet of head. This is why your pool is turning green, because the filter system just can't handle this increase in the filter pressure. Remember, the higher resistance we have, the TDH, the lower the flow. So this means that we aren't getting the correct amount of flow in this scenario, which is what's causing the pool to turn green. The solution here would be to lower the horsepower of the pump or install a larger filter. So that's why it's so important to factor in everything when you're installing equipment. The pool was set up for doom long before the water ever started circulating. It was a choice of the system or how it was installed that was causing the issue, not the pool service company. So if you're having a pool that's constantly turning on you, take a look at the TDH and see what's going on. Now again, this is a little more than a basic overview, but not super technical. We only scratch the tip of the iceberg here in regards to TDH. If you're doing repairs and want to do the best you can for your customer, then read up on total dynamic head and what is all entailed with it. You'll be quite surprised what is all there and how everything affects it. I hope at least I opened up your eyes today about total dynamic head. If you're a data junkie like I am, it will open up a whole new world of knowledge that will make you the best company around in your area. Thanks for listening today, and as always, stay safe and enjoy your pool.
That's all for tonight, and thanks for tuning in. Please send any comments or ideas, how-to and guest appearance requests, and product review suggestions to eric@𝐶hlorine.com. Remember, if life piddles in your pool of dreams, just add some chlorine and keep swimming. See you next time.